In Lesson 5.5, you're going to be looking at inequalities involving absolute value, and you will solve and graph absolute value inequalities. For example 1, it gives you two cases to consider. Please make sure that you write those down in your notes. The expression inside the absolute value symbols is non-negative, and the expression inside the absolute value symbols is negative. And then the solution is the intersection of the solution of those two cases. So let's take a look at how that works out. In example 1, we have m plus 2 is less than 11. So case 1 is when what's inside the absolute value is non-negative. So we just set it up like normal. M plus 2 is less than 11, minus 2 from both sides. M is less than 9. In case 2, it says the expression inside the absolute value symbol is negative. So we're going to set m plus 2 equal to a negative 11, and because we multiplied that m plus 2 times a negative 1, we did flip that symbol around, so it's greater than. Still going to subtract 2 from both sides, ending up with m is greater than negative 13, and so there you see the open circle at negative 13, and you see the open circle at 9, and then we have an intersection of those two. Okay. In example B, we have an absolute value inequality that's less than a negative number. And since y minus 1 absolute value cannot be negative, it's not possible for that to be less than negative 2. So therefore, there's no solution, and the solution set is the empty set, that circle with a line through it. Let's try these two down on the bottom of page 312. So we have two cases to consider for n minus 8 is less than or equal to 2. So we're going to start by just ignoring those absolute value and assume that that's positive. So n minus 8 is less than or equal to 2. When we add 8 to both sides, we get n is less than or equal to 10. That's not the hard part. And not that this other part is hard, but you just have to make sure and think about what you're doing. So case 2 is considering n minus 8 is actually negative, in which case we flip that symbol around and we get greater than or equal to negative 2. And so when we add 8 to both sides, we get n is greater than or equal to 6. So here are our two inequalities. N is less than or equal to 10, and n is greater than or equal to 6. So on a number line, here's 0, here is 6, there's a closed circle at 6, and then here's 10, that's a closed circle at 10, and then everything in between there is the solution set. So what we have for the solution set, we have n such that 6 is less than n is less than 10. And we use our braces on the outside to close it off. In 1b, notice that we have less than negative 3. And since there's not a possible value for c to plug in that will make an absolute value negative, the answer or the solution set is the empty set for 1b. On page 313, the real world example number 2 translates a story problem into an absolute value inequality, shown here. And the two cases are when inside the absolute value is non-negative, and case 2 where inside the absolute value is negative. Solve each of those individually, and then write in solution set notation and graph on a number line if it asks you to. For the guided practice problem, number 2, it says the melting point of ice is 0 degrees, and during a chemistry experiment, Jill observed the ice melting point within 2 degrees of this temperature, and the range of temperatures that Jill observed. Now, I can't quite figure this one out because I set it up as case 1 and case 2, and obviously minusing 0, I don't need to go any further, it's just t is less than or equal to 2. But this is the one that I can't quite get, and my assumption is t is greater than or equal to negative 2. That's case 2 where you set it equal to negative. The reason that I'm thinking that this can't be it is because once ice melts at 0, you're not going to go further down in temperature. So that's why I'm thinking it says only 0 to 2 as far as the solution set. The temperature has to be between melting and then within 2 degrees of that measurement. But if you figure out another explanation, I'd love to hear it. For the second objective for this lesson, we have absolute value inequalities involving the greater than symbol. And so the inequality, the absolute value greater than 3, means that the distance between x and 0 is greater than 3. So take a look at how this graph looks to compare to what we were just doing, where we had 2 circles and a connection between the two. And so we have case 1 where the expression inside the absolute value symbols is non-negative, and case 2 where inside the absolute value symbols is negative. So for example 3, take a look at that. It says to solve this inequality, and since it involves a greater than symbol, when we assume what's inside the absolute value is non-negative, and then case 2 where we say what's inside the absolute value is negative. So changing that to a negative 12, flipping the sign around, continuing to solve them, and then notice here that we have an or statement. The solution set is n such that n is greater than or equal to 2, or n is less than or equal to negative 6, and we have arrows going in opposite directions. So let's take a look at some guided practice problems on the bottom of the page. So we have an inequality involving absolute values and a greater than symbol. So the first thing we're going to assume is what's inside of the absolute values is non-negative. So 2k plus 1 is greater than 7, minus 1, minus 1, 2k is greater than 6, divide by 2, and we get k is greater than 3. Okay, so let me show my work there. It's not wanting to show there, but you get the picture. So then I'm going to also assume what's inside of the absolute value is negative. So we have 2k plus 1 is less than negative 7. Minus 1, whoops, I got ahead of myself there. 2k is less than negative 8. Divide by 2, k is less than negative 4. So we have our two inequalities here, and it says to graph them. So I'm going to grab another color here, and on a number line, here is negative 4, open circle, arrow to the left, and k is greater than 3. So here's 0 as a reference point, here's 3, open circle at 3, arrow to the right. Let's try another one here. 3b, though, actually is no solution, because no matter what, we're never going to get a negative number when we have absolute value. So the solution set there is the empty set for 3b. So I know you're not going to be doing the problems on page 314, but I have it pulled up here just to talk about a couple of things. Number one, when you're working with absolute value, you want to pay attention to anything that results in a negative number. So for example, right here we have a negative number. Right here we have a negative number. When we're working with absolute value, we know that anything inside of the absolute value bars is going to yield a positive number. So anything with that negative number is going to give us the empty set. So just kind of scanning the problems here on this page, all of these ones that I'm circling end up with a negative number and therefore are going to be the empty set. Okay. The other thing to think about is inequalities with absolute value involving a greater than sign, and then inequalities with absolute value involving a less than sign. When we have a greater than sign, we're going to end up with a number line that looks something like this, with arrows going in opposite directions with the word or. And with less than, what we're going to have is open circles and closed circles with things coming together in the middle. And so we're thinking more about and.